evening and welcome to Tinkering with Edkelar. I am happy to present one of the more recent devices that made its way from the dumpster to my bench. Many thanks to Onyx for sending it my way. A Gossen SECUTEST 0701S. Now what is this thing? In Germany, and therefore most likely similar in most of the EU, electrical appliances that are used in commercial settings like offices, hotels, shops, etc. need to be checked for electrical safety. The details of the test parameters are outlined in two DIN standards, 701 and 702. Similar in content, one is for first-time checks and the other is for repeated checks after repairs. I only skimmed over the specs, but it boils down to a visual inspection followed by measuring the earthing and insulation of the devices. This tester here is an all-in-one solution for the 701 and 702 tests. It seems to be a first-generation model, since the current model range does not include this one. And the price range is clearly, if you have to ask, you can't afford it. So why would I want an outdated tester for things I don't have to do? Well, I think with the number of mains-powered devices that I fix up recently, I feel much better to run those through an outdated tester than no test at all. So, let's have a peek! The main unit is built into a carry case, and this one comes with an expansion that is resting in the lid. The lid comes off and reveals the first problem. One of the claws that holds it to the base is broken off. The side panel features a power outlet for the device under test, including a plugged-in detection switch. Let's continue with the lid. The hinge comes apart easily. The add-on unit, let's call it the data unit, is held in place with two screws. And it has a battery compartment in the rear. Now, while the batteries seem to not have leaked, the battery holder has clearly snapped in half. The data unit has an integrated printer. Looks to be the same mechanism as I have seen in the Epson HX20. I even have a few spare ribbons. Oh, and the bottom lid of the case has snapped off in several places. I dare say this one has been thrown into the bin with a vengeance. There is a main PCB in here and a keyboard PCB. Whoops! That lid lost one of its hinge knobs. Clearly, the plastic is more than just a little brittle. Now to the main unit. First, the handle. After the little cover plate for the mains wire, I finally find the screws for the case. Recessed way too deep for my screwdriver. I have to get an extra long set for this one finally. Taking a peek into the side for now. The test socket comes off without special tools. It has a little PCB mounted on the inside. The plug-in detector is implemented with a light sensor. And there is also what might be a PTZ. At least the instrument can detect and react to an overtemperature condition in the test outlet. Oh, I'm sure that PCB in there shouldn't be flapping around like that. While I wait for my screwdriver, I check on some of the accessories. The probe looks okay, but the grommet is just plain tar by now. Yuck! So that's where all the black marks came from. It doesn't seem that the probe tip is removable, so no non-destructive way of replacing the grommet. And a new probe is available, but at over €200, I live without the grommet just fine. Up next, a barcode scanner. The intention here is to have it work together with the data unit. Scan inventory numbers to print test reports. It also needs a bit of a clean. Note that the barcode reader is also powered via the RS-232 plug, clearly not 100% standard. And indeed, the manual shows that there is a 5V supply running through that. A PC connection is supported, but needs a matching cable to avoid surprises. The reader is an interesting construction. I'll cover that in a bit more detail when assembling it again. I ordered a set of long screwdrivers online, but during my all too frequent trip to the hardware store, I found one there too. It almost fits and should be good enough for disassembly. Only 2 of the rubber feet had screws in them, and something is still holding that cover in. I thought about some clips maybe, but whoops, the case is asymmetrical. There is a second set of screws next to the other rubber feet. Fiendish. Open sesame. Multiple PCBs inside. The ribbon connectors are easily identifiable, and the other wires are socketed too. Nice. The loose PCB seems to be the high power one. The input and test sockets come together here, in between a set of heavy duty relays. And the last board, clearly the power supply. There are 2 linear transformers and what appears to be a switch mode regulator of sorts. Also, a few relays. Continuing with the lid. It has a sandwich of 2 PCBs and the serial port holds them in. Oh, the buttons are just actuating rubber pads. And the silver one isn't like that just for style. It is conductive and connected to the PCB. Turns out that it can detect when there is a high voltage differential between the earth pin and actual ground. It's sort of a face-checking screwdriver with a neon bulb, only in reverse. Nice! Checking for any signs of damage. That one capacitor is smooshed over, clearly been hit with the power distribution PCB. Let's hope that this is the worst of it. The function selection switch has a nice clicky feeling to it, but I want to give the parts a good scrub, so with all the other switches, off it goes. It was hiding 2 springs and balls. That would have rusted eventually. Let's have a peek at those power relays. I can almost hear them go clack. And for completeness' sake, removing the LCD module. This one seems like an off-the-shelf part. Taking care of the power PCB next. There seems to be some water damage. I can see the typical scale outline around the relays. Better make sure that there isn't anything underneath them. The power supply also shows wet spots under most of the electrolytics. I'm pretty sure it's just the same water residue, but you know me, better safe than sorry. But between oxidized solder and thick multi-layer PCBs with thick ground planes all over, desoldering the caps was anything but fun. Good thing I keep training stagehands to use both of them. The desoldering gun alone just could only heat up and remove solder from about 1/3 of the PCB thickness. Here you can see some of the more extreme residue. Water? Maybe. I'll give it a good clean anyhow. And after soldering the caps in again, cleaning the bottom side too. The barcode reader only has a single electrolytic in it. Nothing hiding under the optical parts either. The control and metering PCB only has one cap to be replaced, right next to a metal can chip. Turns out that this is the true RMS converter. Also cleaning those 2 PCBs. And soldering in the meter sockets again. Yes, this device can also do some multimeter-y things. AC voltage measurement, of course, but there is also a temperature probe and amps clamp. Both equally expensive as the probe. and recapping the printer PCB. Removing the power relays also took a bit of effort, but I also used the chance to do a function check and give the contacts a good wipe down. And soldering them back in was also a case for the large soldering gun again. My normal iron could only tack them in place. Cleaning all the contacts. Assembly time! I wanted to try out the electronics before putting everything back together again, but that 3D PCB origami didn't quite lay flat on the bench. So I connected the parts inside the shell to hold the two high voltage PCBs in place at least. Insulating that one loose connector, just in case. Power on! Yes! No? After running self-test, it shuts down again. Maybe another setting on the function switch? Ah, that looks more like it. Apparently, off isn't really off, but rather standby. It will still run the self-test and keep the processor powered up. Since the self-test seems to be happy, I'll just try out some keys. Contrast setting, check. Putting the function switch back together was slightly more difficult than expected. One of the balls didn't go where it should, and so the spring got a bit mangled. Whoops! Take two. Now it works. All the buttons are a nice fit, but the silver one? Either the cutout is slightly too small or the button is slightly too large. It took effort to get it into that slot again. Cleaning the contact. Making sure that the function switch lines up correctly and giving the LCD cover a good clean. And repeating the process, now with the switch membranes and the voltage check connection. The test outlet. First, the plunger. Then the socket. Note that the grounding prongs are divided and each side has its own wire. The PCB, and then again with the correct screws this time. And last, the cover plate for the second outlet. There seems to be a model out there that has two outlets. Not sure what the purpose would be, but the case also has room for one more PCB. And another quick function check, this time saving the contrast setting too. The barcode scanner is next. It's a sandwich of two PCBs, connected with several flat flex ones. The centerpiece is the optical pickup, like a camera, but the rear is not a usual 2D sensor, but rather a CCD line sensor. That means the scanner actually only sees a single pixel tall image. It's the same thing that is built into flatbed scanners. The sandwich gets mounted in the case with a mirror up front. It directs the lens out the small opening. Then we have an LED strip for light with a diffuser, held in place with a metal cover plate. The sensor looks over this part. And in the rear, the cord and buzzer connector for the typical beep. Add a lens cover and protective bumper, and done. Now to the printer. Ah, Epson, I knew it. I have done this before, yes, but it's been a few years, and the parts are delicate. I don't want to break anything else. The printer head has 4 pins arranged next to each other, so it only has to travel 1/4 of the paper width. and putting the puzzle back together again. And putting the components into the case again. Adding some paper. Connecting up the data unit for a first test. Oh, it has a print screen feature. Looks fine. Might need a new ribbon, but still readable. Now gluing the broken case pieces together. Let's see how well crazy glue does with and in this case. Seems to be working. And for fixing the lid, I removed the broken tab and made a replacement with OpenSCAD. Since this part is going to take some force, gluing it will not suffice. But it is a start to hold it in place. To make a better, more permanent connection, I used the heat shaping method again. And after a bit of fine-tuning, the lid is complete. I also used the heat shaping method to reattach the broken lid hinge for the printer, and yes, not perfect, but it holds for regular use, I'd say. And here's a quick test of a real-life device. Note that I am not formally qualified according to whatever subclause of whatever DIN or VDA number I should be qualified, but who cares, right? First, visual inspection. It is funny to see that you can set all of the items pass or fail when, to the best of my knowledge, the test isn't allowed to continue if any of these fail. Meh. The next key part for the SK1 type device, that is a device with a protective earth connection, one needs to poke all exposed metal parts with the probe to check earthing continuity. And done, printing a report and saving the result. And that's it. Not all that much to do, but still quite an elaborate project. I'll try to include a report of all mains powered devices I restore from now on. That would be DIN 0702. Or until I get bored of it. That would be ATKELAR 0815. Whichever comes first. I hope you enjoyed this episode. See you next time! The loose PCB seems to be the higher The higher power one. Yes, this is the higher power. All praise to the input PCB.